Assalamu alaikum everyone. Welcome to Maths Magic Hub. In this video, we will discuss how to check whether the two lines are parallel, intersecting, or skew lines. In two-dimensional space, we know that either two lines are parallel or they intersect. That is, two non-parallel lines must intersect at a point in two-dimensional space. But in three-dimensional space, we have another case, that is two lines may be, number one, two lines are parallel, number two, or the two lines are not parallel and they intersect, or they are not parallel and do not intersect. In three-dimensional space, these lines which are neither parallel and nor intersecting are called skew lines. Here we have drawn some lines on the edges of a cuboid. In these lines, the line GH and EF are parallel lines. The lines AB and BD intersect at point B. These lines are drawn with blue color. We can see that these two lines AB and BD intersect at the point B. Whereas the lines CD and EH, we can see that these two lines CD and EH, these are neither parallel and nor intersecting. So these two lines CD and EH are basically skew lines. Next, we are given two lines r vector equals to x1 y1 z1 plus t times a1 b1 c1 and r vector equals to x2 y2 z2 plus s times a2 b2 c2. These are the vector equation of two lines. Now, how to write vector equation of two lines? You must have to watch reference lecture number 1 and lecture number 2. Okay, well, now here in these problems, we are given two vector equation of lines. R vector equals to x1 y1 z1 plus t times a1 b1 c1 and r vector equals to x2 y2 z2 plus s times a2 b2 c2. Here x1 y1 z1 is an arbitrary point on the line, say L1, and x2 y2 z2 is a fixed point on the line L2. A1 b1 c1 is the direction vector of the line L1 and a2 b2 c2 is the direction vector of the line L2. T and S both are parameters. Now, we have to show that these two lines are parallel, intersecting, or skew lines. The two lines are parallel. Above two lines L1 and L2, the two lines are parallel if their direction vectors are parallel. That is, A2 B2 C2 is equal to K times A1 B1 C1. If this condition satisfies that is, the direction vector of the one line is a scalar multiple of the direction vector of the other line, then these two lines will be parallel. Okay, well, if we are asked to check whether the given two lines are identical, so the two parallel lines are identical. Two parallel lines are identical if they have a common point. Well, in lecture 3, we already studied that we can write vector equation of a line in infinite many different ways. So two different equations may look different, but they may represent a same straight line. So for two vector equations to represent identical equations, this condition must be satisfied. That is, the two lines must be parallel and they must have a common point. If this condition is satisfied, then those two equations will represent an identical straight line. Now, if the lines are not parallel, we write general point on L1 and L2 as. Now, any general point on the line L1 is Px1 plus A1t, Y1 plus B1t, and Z1 plus C1t. Similarly, a general point on the line L2 is X2 plus A2s, Y2 plus AB2s, and Z2 plus C2s. So these are the general points on the line L1 and L2. Now, in order to check whether these lines intersect, equate like components. Equating like components of these points, we get three equations. X1 plus A1t is equal to X2 plus A2s. Y1 plus B1t is equal to Y2 plus B2s. Z1 plus C1t is equal to Z2 plus C2s. We solve any two of these three equations and get the values of t and s. If these values of t and s satisfy the third equation, then the lines are intersecting. If the value of t and s obtained from any two of these equations do not satisfy the third equation, then the lines are non-intersecting. In the case the lines are not parallel and they neither intersect, these two lines L1 and L2 must be skew lines. Next, we will give the maths magic points of topic. Magic point number 1, lines R equals to A plus TB and R equals to C plus SD are parallel if and only if B is equal to K times D vector. That is, the given two lines are parallel if their direction vectors are multiple of each other or the direction vectors are parallel. If two parallel lines share any point, then they share all the points. That is, lines are identical. This is also a very important point about the lines. If two lines are parallel and they have one common point, it means they share all their points. That is, the two lines are basically identical lines. Means two vector equations of the line represent the same straight line. Next, two lines are skew if they are not parallel and they do not intersect. So in order to show that the given two lines are parallel, we have to show that first, number one, the given two lines are not parallel, and number two, we will show that these lines do not intersect. That is, we will form simultaneous equations, three simultaneous equations, by comparing the components of the general point on the two lines, and we find the value of the two parameters involved from any two of the equations. And if the values of the parameters found from the two equations satisfy the third equation, then the lines are intersecting, and we can find the point of intersection of these lines by just plugging in the value of one of the parameter in the general point P or Q on the two lines. And if the lines do not intersect, then these lines are said to be skew lines. That's it for this lecture. Thank you for watching. Hope to see you in next video.